Ken Forster, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to episode 174 of Momenta Digital Thread podcast series. Today, I'm greatly pleased to have Gary Chandler, Chief Technology Officer of QiO, a company providing AI solutions to optimize industrial assets. Gary has over 30 years experience engineering real-time embedded software control systems for safety-critical applications, predominantly in aerospace. Gary spent 25 of those years at Rolls Royce, where he served as chief engineer for engine control systems and later as chief data architect and head of software for the firm. He has spent the last 5 years focused on delivering Internet of Things technologies at QiO to large industrials to help them generate value and realization of their digital roadmap. Gary, welcome to our Digital Thread podcast today.
Yeah, well, thanks, Ken. I'm a long-time subscriber and fan of the series, so a real pleasure for me to be joining you today.
Real pleasure to have you. We'll talk in a moment why this deep fascination with your historical background at Rolls Royce and QiO, but suffice it to say, it's great to have you on the program. So I always like to start off in terms of one's digital thread. So what would you consider to be your digital thread? In other words, the one or more thematic threads that defined your digital industry journey.
So I grew up in the 70s and 80s in an area on the west coast of Scotland, which was known as Silicon Glen as opposed to Silicon Valley. And it was the high-tech industry hub in Scotland. My father was an engineer at IBM and my eldest brother worked at IBM too. So really from an early age, I was surrounded by developments in digital electronics and was quite lucky to have access in my home to the very early personal computers of the day, including the IBM PC when it was first manufactured in Greenock in the early 1980s. Those early PCs were really targeted at word processing and accounting tasks, but I remember my main interest in them was always trying to connect electronics to their I/O ports and create some interaction with the real world in some way, even if it was just something as crude as a proximity detector. So I'd say that was the beginning of my digital thread, and that led me on to obtaining an electronics degree in 91. And actually, while I was studying for my degree, I also worked at IBM during my vacation periods. And what I remember was the work at IBM was pretty interesting, but it did make me realize that I didn't want to design IT systems or office software. I wanted to work with control systems. It helped me realize I was more interested in the robotics and the automation on the manufacturing line than I was in the PCs being made. So when I was looking for my first job after graduating, I focused on where I could work with control systems, and I was quite fortunate to land my first job in 91 working on engine control systems for Rolls Royce jet engines, and I continued to do that for the next 25 years.
It's pretty interesting when many of us talk about working on control systems, it's usually those having to do with, let's say, pumps or, let's say, machine tools in a factory or such. To go right to a mission-critical application like engine control systems, of which many of us have experienced over our life, working correctly, right, in terms of our flights. That's an interesting jump to be able to make. In an age where we're inundated with terms such as servitization or X as a service, I want to take you back to 1962, when the Bristol Siddeley Company filed the trademark for power by the hour. And yes, this was a complete engine and accessory replacement program billed at a fixed sum per flying hour. The program, of course, was reinvented by then owner Rolls Royce in the 1980s with the same basic promise, but now including all service as well. So truly power by the hour. So here we sit 60 years later, and that trademark term power by the hour is still used to describe X as a service. I've long wanted to interview someone close to this program, so we're quite pleased when we met. To get some context, perhaps you can take us back to your earliest experiences with this program at Rolls Royce.
Yeah, sure. So I'm sorry I can't take you all the way back to 1962, but I will take you back to the mid to late 90s. And that's really where I came into contact with the Power by the Hour program in any sort of meaningful way. And by then, as you say, the business model had been developing for many years. The basic premise of Power by the Hour or servitization, as you know, is that the end user of the product doesn't actually ever buy or ever own the product. Instead, they just buy the results of using the product. Hence, for the jet engine, that was Power by the Hour. Now, the most important part of Power by the Hour servitization is knowing what price to set for the use of the product, for that hourly use of the product. And of course, that depends on a whole host of factors. Primarily, you have to predict how the asset's going to be used and how it's going to degrade. And you have to determine how, when, and at what cost you're going to carry out maintenance on the assets. Once the asset's operational, you then obviously have to monitor all the assets to check they're performing in line with your expectations. Because if they're not performing, then you're going to have to intervene before you lose your profit margin. So, really simply put, you need data to run an effective servitization model. And the data driving the Power by the Hour model for the jet engines was in large part generated by the embedded control systems that I was writing the software for. Really early on, it was clear that the more information you could derive from the data, the better informed we could be about revenue projections. And this theme around the value of data continued throughout my career, and I was constantly wrestling with how to get more data off the engines. You mentioned the 1960s, but really from my perspective, the Trent 700 jet engine that entered service on the Airbus A330 in 95, that was really the first true example of servitization model as we know it today. The big difference really from those early days was that engines before the Trent family of engines, they could consume a quantity of spares equivalent to the original cost of the engine in about 8 years. But the technology advancements on the Trent family of engines, this extended that 8 years to around 25 years. So it really changed what happened in the OEM maintenance cycle. OEM maintenance, repair and overhaul, or MRO services, as we'll call it. Before that time, in the 90s, it was pretty limited to warranty repairs, and MRO work in general was largely carried out by technical services divisions of the airlines and independent MRO providers. But the reality was, over the lifetime of the engine, the spares and repairs business could be even more lucrative than the sticker price for selling the product in the first place. Not to mention that some independent MRO operators were more intimate with end customers and the airlines than the OEMs themselves. So when you coupled that with the projected loss of spares revenue due to the inherently more reliable engines and the opportunity to form stronger customer partnerships, it just made a lot of sense to deliver Power by the Hour. And it generated a lot of commercial success being the first to market with that model. Until the competition caught up, actually, there was a bit of fun to be had with marketing at the time. I remember things like, why do you pay our competitors when their products break? Just pay us when our products work. And today, I still think that would be a great tagline for anyone stealing a march on their competitors with a servitization model. But really, data was so important to the successful running of the Power by the Hour network. The Rolls Royce in 2004 had opened a state-of-the-art operations centres at Derby in the UK. And if you think about a mission control at NASA, you get a picture of what that operation looks like. That the ops centre pulled data real-time from aircraft engines and maintenance facilities and allowed them to mobilise resources to service any aircraft anywhere around the globe.
It's interesting given the level of, I'd say planning that you guys went through on this, or considerations of the various factors, including revenue streams. And then, of course, the learning subsequent. Not only were you first to market with it, you guys really were the trend center. Again, this whole idea of Power by the Hour exists as a tagline pretty much, across the industry anytime we talk servitization. So personally, we see a lot of industrial OEMs, concerns about making that move. They claim their shareholders aren't ready to make the jump from CapEx to recurring revenue models. Yet again, you guys had already a lot of experience in this. I'm curious, how did this as a service mentality manifest itself really in your daily engineering and operations activities? I.e., what do you think was different in how you guys were approaching it versus your competitors who were still catching up at the time?
Yeah, so I think right from my very first experience with Power by the Hour, I was really quite inspired by it. And I mean, probably didn't use the term sustainability too much in 1995, but I remember, many discussions, which you would have in the sustainability space today. And those discussions started around, why do customers need to own the products to use it? And that was a very alien concept in that world where we had been selling big ticket items and then benefiting from the spares revenues from those. Quite a hard model to wean yourself off of. But because we were introducing the advanced technologies and the improved reliability, we recognized that those spares and repairs revenues would start to diminish for us. So we really had to change how we thought about the whole life cycle of the product itself. So really the as a service mentality, it did permeate through to daily engineering, manifestly challenging us to design the whole life cycle, not just so that we could sell the big sticker price, but really think about the impact unscheduled maintenance had on our customers' operations and really make us think about countermeasures we could deploy to minimize any customer disruption. And to this day, I still believe servitization is the most eco-friendly business model that I have seen. But I mean, you're right to point out that the reticence, and I recognize that moving from, that CapEx to the OpEx or the recurring revenue models. There's a lot of uncertainty with the servitization model, and particularly what to charge by the hour to remain profitable through the whole product life cycle. And if you think you have to set that, in the case of the jet engine, you have to set that up front and you're going to be running that engine for 25 years. So that is a big decision to make and a lot of uncertainty around. As I said, the point is many companies make good profits from selling support and parts after the sale. What is the incentive to change given that uncertainty that you have to switch to? What I would say though is if you can reduce the uncertainty, if you can effectively take that away using data, you can start to understand incentives across the end-to-end supply chain and make it win-win for everybody. And if I give you a couple of examples so you see how that manifests itself, maybe a little extreme examples to show the effect a lack of data or the lack of predictability can have on the servitization model. If you think that Rolls Royce had no warning of the coronavirus pandemic, or of Icelandic volcanic eruptions dispersing ash clouds, no prediction because there was no data. And so as anybody can see, the impact these global scale events have on a servitization business is very significant. But of course, non-servitization businesses aren't immune to those events either. So I would remind anybody that points at these examples as a reason to avoid the servitization model, that really, regardless of your business model, if your end user's business can't be successful, then ultimately that's going to have a huge impact on your business too. Where I see the servitization model really differs is that it drives innovation in the product company. When the volcanoes erupted and grounded all the flights between the US and Europe because the damage volcanic ash can do to the jet engines, Rolls-Royce immediately set to work understanding just how much ash would cause just how much damage. They collected data and they built a model which meant aviation authorities no longer had to ground flights. And today, with that model, everybody now knows how to fly through ash clouds safely. The servitization model incentivized everybody in the supply chain to find a solution to minimize disruption and the impact on the end user business. And that quickly brings out the subject matter experts wherever they sit in the supply chain. But everyone else wins too. Rather than just sit on the cash in the bank from your big sticker price sales while your end user suffers, everyone rolls up their sleeves, and necessity is the mother of all invention, really, as Plato said. It's an extreme case, but hopefully I think it gives a fair representation of the reality of running a servitization model, and I hope reinforces the importance of data. Data removes uncertainty and drives the business. And that's great for all of us in IoT because we know we're living in a time when IoT technologies allow us to access data on a scale that, I could only dream about in my 25 years at Rolls Royce.
What a great example. We often hear the platitudes of upstream suppliers talking about wanting to be a trusted partner to their downstream customers. And this is a very real world example where it's shared risk, shared reward. And what a great way to truly become a valued, not only supplier, but partner. You mentioned data several times, and I know you went on to become chief data architect for Rolls Royce in 2014 and then head of software in 2016. Just briefly, what was your mandate at the time? And what would you say were some of your key learnings from having held this leadership position at such a prominent industrial OEM?
Yeah, so the three key events happened. I said that Trent 700 went into service in 95. Rolls-Royce formed a dedicated analytics team in 99 to help run that servitization model. And then the operations center opened in 2004. That was kind of NASA-like operations center to pull all that together. To borrow a phrase I've heard you use, Ken, connect, collect, and correct. If you think about what we had back then, the engine controls group I was with, they were providing the connect piece to the data on the engine. The analytics group were responsible for collecting that data from all the engines across the global network and then providing that into the analysis into the ops center, who could then do the correct piece and take corrective actions needed to make sure that the whole power by the hour network was delivering what the customers needed. Obviously, at the time, we weren't familiar with the Industry 4.0 terms, but in 2004, really, we were essentially operating with today's technologies, that would look like cloud and connected edge model. If I then fast forward to 2013, I got a call to go and spend some time reviewing the investments and partnerships GE had been making in cloud. So a couple of years before GE Predicts was even a thing. But it became clear pretty quickly that some of the technology and cost challenges we had around collecting and analyzing big data sets, they were undergoing a rapid change. So that's really what led to the creation of the position of Chief Data Architect. And I was tasked with aligning the chain of data coming from the engines right through to the ops center across the different groups that had just kind of sprung up across the company over the previous 10 or so years. And then as aligning those groups then set about exploiting the rapid developments in IoT technology. Actually, that led to a formation of a joint group where we put all the controls engineers and all the data engineers together, and we rebranded that as Controls and Data Services. The thing I take away from that is the period in 2013 to 2015 was a hugely exciting time for me. You can imagine the access very generously offered to me by the big tech providers, Microsoft, AWS, Google, etc. And also startups, given their eagerness of working within aerospace and with Rolls Royce. So when I saw the potential of the IoT technologies to transform the day-to-day operations, I was totally hooked. Connected equipment, processing power, compute costs, access to huge data sets. Suddenly, they all felt as though they were in touching distance. And by the late 90s, if I take you back then, if I paint a picture that I was pushing the equivalent of one standard letter or A4 piece of paper worth of data from each aircraft each day, so just one piece of paper from each aircraft each day, that's the information we were getting. As I left Rolls-Royce, the last engine control system we deployed, I could push enough data from one engine in 1 hour to generate a stack of paper over 20 stories high. The key learnings for me along that journey from data poor in the 90s to data rich in 2016, it was consistently, how do you make the data you had available at the time work as hard as possible for you and just keep on removing the next level of uncertainty from the operations? As you say, I was then asked to go and head up software, and primarily that was to really drive the balance between opening up the volume of data we could pull off the engine and the sort of analytics we could push to the edge and run on the engine itself.
Talk about leaving on high. And I say leaving because we know that in 2017, you came over to QiO. What inspired you to make a jump to a pure software company from the work you had done prior?
Yeah, really difficult. But I remember sitting at my desk in Rolls-Royce in mid-2016 and opening a very posh-looking envelope which contained an invitation to my 25 years long service award dinner. I couldn't believe that it was 25 years had passed since I graduated. And I realised then that I was about a major career junction. I could stay where I was and be very comfortable. But given what I had my eyes open to in the IoT world as I looked outside Rolls-Royce when I was building the IoT strategy, I had developed this concern that access to the power of AI in industrials might get locked into a privileged few. And I really wanted to try and sort of demystify AI and make it more accessible to industrials who couldn't necessarily afford to employ the sort of dedicated analytics teams that we had at Rolls Royce. Between 2013 and 2015, as I said, I must have looked at over 50 IoT companies, and QiO was a standout company that I had seen. So after getting my envelope in mid-2016, I rather cheekily called up one of the co-founders of QiO, Baz Kuti, and I asked if he had room for one more. And as you say, QiO is a pure software company, and all my work in life, I've worked with software and hardware. That's still my passion, but the attraction of a pure software company is around the pace and the agility that comes from really decoupling yourself from designing and developing and building the hardware itself in which the software must run. And today, there's plenty of excellent edge solutions available on the market these days in which to host our edge software solutions along with our cloud solutions. And that's just a great model for us.
And of course, we featured Baz Kuti on one of our earlier podcasts. And I tell you, they describe people based on network density. He's probably a bit of a dark hole in that regard, about the densest network connectivity I've ever seen in terms of an individual. So he has been great in terms of connecting us with people. Now, QiO delivers an AI-augmented foresight suite of solutions to accelerate digital transformation, revenue growth, and sustainability for the global industrial sector. It's a mouthful, quoted directly from your website. So practically, what does that actually mean?
Probably means we need to rewrite that phrase. But yeah, our AI solutions, they essentially act as a coach and a mentor to our clients to make them operate at their best every day. We know industrial operations have good days and bad days. And sometimes we don't know whether we had a good or a bad day until analysis are run a few days or weeks down the line. And what we want to do is accelerate that digital transformation and help industrials make better decisions faster. So our AI recommends to operators the changes and the interventions they need to make in real time to plant equipment and assets to keep the system optimized for, say, energy efficiency, and really to be the best version of themselves that they can be today. It's actually quite difficult to know if you're truly operating at your best right now, and ensuring that everyone across the organization is following the right recommendations. And if I give you just a couple of examples, if you take a quick question that most industrial leaders will know the answer to, how much product did you make yesterday and how much energy was used? Most industrial leaders will be able to access those metrics quite quickly. And that shows they have data and they can access the information to answer the question. But then if you ask, do you know if that was a good day or a bad day? I guess a little bit harder to answer. And many folks won't necessarily have that level of knowledge at that time. You can then make the question even harder and say, well, how does yesterday compare to your best day and why? What instructions do you wish you had issued to make it a good day? It's getting really tough to answer because you're now getting into the realms of wisdom. Were you wise enough at 9 a.m. yesterday to tell everybody what they personally should do so that the business had a good day? And really what we've done at QiO is build the application that gets you straight to the wisdom level automatically. And as I said before, there's teams of data scientists who could help you get to that wisdom. But we want industrials to have a quick and easy access to this level of AI. They absolutely should and they absolutely can. It does sometimes feel like magic when we're trying to explain it, but it's not. I'll just give us a last really simple example just to illustrate it. If you take a really simple system that most of us think that we're subject matter experts in, if you take a car, most people understand something about how to drive it to achieve good fuel efficiency. And they can probably tell you whether they drove efficiently or inefficiently on their last journey. They just intuitively think they know. And they probably think they know what sort of cost savings there could have been if they had chosen to drive a little more efficiently. They feel they've got a good inherent knowledge of how their car works, and they understand the outcome they achieved and they understand what it costs. Well, same for industrial leaders managing plants and assets. Now, if you imagine the front tyre on the driver's side goes a little flat, it loses 2 psi of air pressure. Probably most of us would not have the knowledge to understand the impact that 2 psi pressure drop was having on the efficiency and cost of running the car. For sure, we know the efficiency would be down, But even if we had the data and the information that there was a 2 psi pressure drop, we wouldn't really know what the cost impact of that was. Now, obviously, that is trivial for an AI model of that car to work out. An AI model can easily infer what impact a 2 psi pressure drop has had on the system as a whole and can therefore associate a cost with it. And it can deliver us that knowledge. Let's now take it to the wisdom level and say you kind of got three options as to what you might want to do given that you've lost some tire pressure. You want to know if it would be wise to just carry on driving around for 2 or 3 days until the next time you go to the gas station and fill up, and then you can top up the air in the tire. What's the cost? What's the risk? Should you drive to the gas station straight away and just pump the air into the tire? Should you drive straight to the repair shop and get a new tire right now? When you break it down like this, you can see that AI can just issue you with a recommendation, option 1, 2, or 3. Of course, you can still go and drill down into the tire pressure data and compare that with previous journeys, etc. But right now, just do this. Just follow these recommendations and you'll get the best outcome in the circumstances. As I said, it's a really simple example, but it is still difficult to just make the right call, even if you did actually know the tire pressure had dropped to 2 psi. And most of us wouldn't even be aware of that. So we're spending money on fuel that we don't need to. We're pumping more CO2 into the atmosphere that we don't need to, and we weren't even aware. Now, just project that onto industrial operators. They've been asked to try and make those calls every day from within much more complex systems with all different sorts of assets changing their behaviours as they heat up, cool down, speed up, speed down, wear out, etc. Our AI models just recommend what the best outcome will be. Just do this now. So if you take that onto the sustainability piece, what we really feel strongly is if you wait until the end of the quarter or even the end of the month to analyse and act, it's going to be too late. You'll be off your net zero tracking targets and you'll be out of time to get back on track. So really what we want industrials to do is to take better decisions every day, every hour, every 15 minutes. That's what's going to lead to a continuous systemic optimization. And that's really about becoming the best version of yourself that you can be today, then go on and improving and becoming best in class. And I see a lot of really great IoT companies out there working at the data and the information layers. But my passion is really to use AI to generate wisdom from a customer's own data and to make this more available to everybody and really help accelerate that digital growth. Start helping companies achieve their sustainability goals and save money. That's kind of really what our mission is.
I think while you are Chief Technology Officer, you might want to don the Chief Marketing Officer hat because I'm really glad I asked you this question of what it practically meant and perhaps get to the wisdom level or uncover industrial wisdom, or you can take many different variants of it. But that was really helpful. I think the industry would refer to this as prescriptive analytics, where typically it's the hierarchy of descriptive, predictive, and then prescriptive in terms of giving you the options to consider what you should do. What are the trade-offs going to be, right? As you make these decisions, often we think about it in ag tech sense, instructing the farmer of options in terms of planting, harvesting, fertilizing, watering, things like that, right? Every single day, recipe management, if you will.
Absolutely.
Can you share some of your key use cases and wins?
Yeah, sure. I think probably since 2017, I think it's fair to say we took more time than we would have liked to truly find our focus. And some of our early use cases in money spinners, they were great solutions, but we're a little way off of our true north. In the past 12 months, we've had a new CEO, and he's really brought a laser focus to us in terms of a true software product company focusing on helping industrials. And that's really around optimizing operation of the assets, monitoring the health of the assets, and servicing the assets as efficiently and effectively as possible. So I'll just focus on use cases came through from those early days. And it won't come as a big surprise, given our conversation at Rolls Royce, that they use our software to help manage their network of over 80 maintenance shops around the globe, servicing more than 6,000 of their business jet engines. And that's just such a great reference for us as a business critical application running in the cloud and with a marquee client since 2017. On the energy optimization and carbon reduction, we've had some early successes in energy intensive industries such as glass manufacturing and steel manufacturing. And we can typically deliver savings in the range of 5 to 15% straight out of the box. I also want to mention that we're really privileged to partner with BT and to provide their customers with our Foresight Sustainability Suite. So when we're talking about being a pure software company, partnerships like BT are invaluable to help us achieve wide reach with our software. Coupled with BT's expertise running their clients' factories, IT networks, data centers, and security, we've got a fantastic edge compute offering. And as an embedded software engineer, I'm pretty excited about what the edge roadmap is going to deliver for customers. And I really can't wait to get rolling those features out.
Let me ask, how do you know when an organization is ready to adopt your solution? Because what you're providing is pretty advanced, right? So what are some of the best practices you've seen in clients realizing that potential value of that solution?
In some respects, it is advanced, but in other respects, it is very accessible. But you're right in terms of saying that we really need C-level sponsorship, because of what our product can do to the business. So it's really great for us to find leaders who recognize there could be more insights in their data than they've been able to extract. And those leaders are, let's say, humble enough and ambitious enough to realize that they are not operating at their best every day. That's a great opportunity for us to work together and deliver some value. Connecting to the data sources is still definitely the biggest friction point we find to adoption for us. And so making sure that you don't burden the client to solve that connect problem for themselves, I would call that out probably as one of the most important best practices.
So finally, in closing, I'm curious, Gary, how do you find your personal inspiration?
Well, I credit one book to really changing the course of my engineering career for the better, and that's Lean Software Development by Mary Poppendieck, published back in 2003. I would really encourage anybody in engineering to read it and don't be put off by the word software in the title. After years of trying and failing to transition the benefits of lean manufacturing into the office and engineering environment, that's the book that changed me forever and has been read many times and is the permanent fixture on my bedside cabinet. Lastly, my greatest inspiration has always been talking to customers and colleagues. I've been really fortunate at both Rolls Royce and QiO to work with some super smart people and customers, and I'm constantly reminded every day that I'm not done learning.
Sounds like a lifelong ambition and vision, which is a great one to have. So, Gary, thank you for sharing this time and insights with us today.
Well, thanks, guys. It's been such a pleasure for me and a real honor to have been invited. So thank you.
Oh, absolutely. No, I appreciate the fact one longtime listener to you quoted me at least once in there. And so it's I'll call it critical listener. And three, I think you've brought a lot of value into a conversation that many of us many times think of as a new age problem, if you will, right? And new age solution. And so it's always helpful to understand how some of the major leaders in the industry have approached this. And it's great that you guys are effectively at QiO taking these learnings and making them in some sense accessible to the long tail of companies that are out there. So we look forward to hearing lots of great things in terms of QiO. So this has been Gary Chandler, Chief Technology Officer of QiO, a company providing AI solutions to optimize industrial assets. Thank you for listening, and please join us next week for the next episode of our Digital Thread podcast series. Thank you, and have a great day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at momenta.one for archive versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.